Bismillahirrahmanirrahim. Welcome to the second part of this topic, which is speaking about the Cauchy-Euler equation. As we defined this equation, it is of the form a sub n x to power n nth order of the nth derivatives of y plus a n minus 1 x to power n minus 1 nth minus 1 derivative, and like that. And we said that what is special about the Euler equation is that the power of the given polynomial is equal to the order of the nth of the derivative. The degree and the order of the derivative are matching. And all the coefficient a sub n minus 1 up to a sub 0, all of them are constant. And we say that to find the solution for this one, we are going to substitute y by x to power m, where m is the number that we need to find from the auxiliary equation. In the last lecture, we spoke about the case or the second order differential equation, and the first case was when we have two distinct real solutions for the auxiliary equation. If I have a quadratic or second order differential equation, we are going to have quadratic equations. And the quadratic equation, as we know, has three cases. Either the two solutions will be different, two distinct real solutions, or repeated solution, or two complex conjugate numbers. In the last lecture, we spoke about the distinct real solution. In this lecture, we are going to speak about the repeated real roots. If we have repeated real roots, then the general solution will be written as C1 multiplied by x to power m1 plus C2x to power m1 times ln of x. This will be the general solution of the given differential equation. This general solution can be constructed using the reduction of order. Let's have some examples for this case when we have repeated real roots. So for that, I need to solve this equation, which is x y double prime plus y prime equal to 0. Now, as we stated, y, assuming that y equal to x to power m. So the first derivative, y prime, will be m times x to power m minus 1, and this also will give me the y double prime is equal to m multiplied by m minus 1 times x to power m minus 2. So the equation now can be written as x multiplied by m times m minus 1 times x to power m minus 2. This is the second derivative, plus y prime, which is m times x to power m minus 1 equal to 0. Multiplying x with x to power m minus 1, I will have m square. Also, I'm going to open this bracket. I will have m square minus m multiplied by x to power m minus 1 plus m to power m minus 1 equal to 0. So my auxiliary equation, if we take x to power m minus 1 as a common factor, it will be m square minus m plus times x to power m minus 1 equal to 0. This will give me, m will cancel minus m. I will have m square equal to 0. Or we can say m1 equal to m2 equal to 0. So we have repeated root. So the solution now for this one will be y equal c1 x to power 0 plus c2 x to power 0 multiplied by ln of x. We go back to see it, it is this form. If we have repeated roots, it will be c1 x to power m plus c2 x to power m ln of x. Because m is equal to 0, so the general solution will be c1 plus c2 ln of x. Take another example. Suppose that I have x to power 2 times the second derivative of y plus 5xy prime plus 4y. Let's write the auxiliary equation. For the second derivative, we have m multiplied by m minus 1 times x to power m minus 2. This is the second derivative, plus 5x. The first derivative will give me m times x to power m minus 1 plus 4, y is given to be x to power m is equal to 0. So I will have m square. We multiply this one with this, and also open the bracket, I will have m square minus m multiplied by x to power m plus this x times x to power m minus 1 will give me 5 m x to power m plus 4 x to power m equal to 0. Take x to power m as a common factor, we will have m square minus m plus 5 m plus 4 times x to power m equal to 0. So the auxiliary equation now will be what is inside the bracket. Then this will give me m square plus 4m plus 4 is equal to 0. Now the rules for this one can be done by factoring or by quadratic formula or by completing the square. Just we need to find the solution for this quadratic equation. And this is perfect square. This can be written as m plus 2 all to power 2, which is equal to 0. So we will have m1 equal to m2 equal to minus 2. It is repeated root. So the general solution now will give me y equal c1 x to power minus 2 plus c2 x to power minus 2 multiplied by ln of x. But we have a repeated root for the quadratic equation. One more example. If I have x squared y double prime minus 3xy prime plus 4y equal to 0. Similarly, this will give me x squared multiplied by m times m minus 1 x to power m minus 2 minus 3 x multiplied by the first derivative will give me m x to power m minus 1 plus 4 x to power m equal to 0. So this will give me m square minus m for the first one minus 3m plus 4 all multiplied by x to power m equal to 0. Again, we just multiply the x, so that this will give me x to power m. So x to power m is a common factor. So the auxiliary equation can be written now as m square minus 4m plus 4 equal to 0. Also, this is perfect square, which is can be written as m minus 2 to power 2 equal to 0. That will give me m1 equal to m2 equal to 2. So it is repeated root. So the general solution will have will be y equal c1 x to power m, which is 2, plus c2 x to power 2 multiplied by n of x. So this is the idea, or this will be the form of the general solution if we have repeated root m1 equal to m2. Then again, the general solution will be y equals c1x to power m1 plus c2x to power m1 multiplied by ln of x.